Okay. Got the signal from the back. It's time to start. Buenas tardes, Madrid. It's the fourth day of the conference. Next to the last session of the day. You're very brave and enduring to be here. Thank you. My name's Gene Chellis. I'm a group program manager in the Windows Server group at Microsoft. Ratwik Bhatt, a test manager in the same team. And we're going to talk to you today about deduplication and how you can reduce your storage costs with data duplication on Windows Server. So we're going to cover a few things. I want to talk about Windows Server 2012 and data duplication. We're going to talk about what we've added in Server 2012 R2 with live VHD file support. We'll show a little bit, have a couple of demos about performance and some of the implications of live file deduplication. And then we'll have a little primer about how you go about deploying and managing deduplication on Windows Server. My goal out of all of this is for you to come away seeing how easy it is, seeing the benefits that you can get, and want to go run out and try deduplication on your server next week. Not too long ago, server or enterprise storage was considered boring, pretty stable, fairly expensive, but not very interesting place. The storage world is changing in the last few years, and we're happy to say that we're part of making that happen. Here are some of the particular ways that it's changing. With the availability of cloud, the acceptance of that, there's new kinds of services that are made possible with that. Customers are moving data to the cloud. Vendors are being able to provide services, cloud-based services related to storage. But the one we're going to talk about today is mostly around how new technologies are allowing us to be able to use standard, relatively low-cost server hardware to be able to provide high performance, highly scalable, continuously available and reliable storage at much lower cost than was possible previously. How many of you have installed or deployed Windows Server 2012? Most folks, not everybody. I put this slide up because if you haven't looked at Server 2012 deeply, you might not have noticed that we made a huge investment in storage and continuous availability in the Server 2012 release. There are all sorts of things on here about Hyper-V replica, virtual fiber channel, the number of clusters, VMs that can run on a cluster. Deduplication is one of those, and it's in the box in Server 2012. Without waiting for R2, you can go out today and save money. Part of this, of how this comes together, is a picture that I'd like to share the way we think about storage. For many years, Microsoft storage was deployed as a third-party solution that we'd bring somebody else in. Storage was a black box in your data center, and Windows Server really didn't have much to do with that. The vision that we have going forward is to be able to have Windows Server be right in the middle of that storage play with storage infrastructure as a service. And the design point for that is to have in a world of virtualization where more and more of your workloads are already or likely to be soon ending up in a virtualized environment, that you put your virtualization environment with clustered Hyper-V servers and then separate from that the storage, can run that on Windows servers that are continuously available How many of you have seen the continuous availability in SMB3 in Server 2012? Okay, good. So with that kind of availability, the kind of performance that if you've looked at it, you've seen that we've had vendor partners putting together systems that could test the limits of the bandwidth of all the components in the system, connect the storage and the Hyper-V clusters together with SMB3, and lo and behold, the combination gets you much less expensive and much easier to operate and manage storage solutions. In Server 2012 R2, we'll talk about what we've done in deduplication. In general, though, it fits into a larger theme, which is to be designing for the cloud point first. So we've been focused on how do you build out clouds, whether that's a private cloud, a hosted cloud, or a service provider cloud. We're trying to build for the design point and be able to deliver cost reductions both on capital costs and the operational costs of being able to run that system. So, storage. This is kind of the core of the problem. You've all seen a chart like this. It's not a Microsoft chart. This particular set of data is from IDC, but there's similar data from a variety of analysts. The storage capacity requirements in enterprises are just going through the roof. Is there anybody here who does not need any more storage for the next year? No hands. That's usual. Anybody here who would like to have some additional storage capacity if I could give it to you for essentially free? All right, you're still awake. That's what deduplication's about. We're going to show you how it works and how you can deploy it. So let's talk about what deduplication is. If you aren't familiar with it, you might ask, so how do you get more data in the same space? How do you cram more bits in? Ones and zeros take the same space as they do before. How do we make this magic work? So the starting point for this is that it didn't make any sense to us to deliver deduplication unless we could make it transparent to the workload. If you have to go to the workload and tell it to do something different, that's a non-starter. So it has to be transparent to the workload. It has to not change the access semantics of an application or of an operating system accessing that storage. So we adopted a post-processing approach. In other words, since performance on writes tends to be one of the critical aspects of storage, we didn't want to get in the way of that. So when your application or your system sends a write down to the storage system, we just write it to disk, whatever that storage subsystem might be. And it can be storage spaces in Server 2012 or R2. It can be DAS storage. It can be clustered, dual attached, clusterable hardware RAID. As long as it's local storage, we just write it to the storage, and then we have an optimization job that runs in the background. The optimization job identifies files, looks for commonality in the files. We apply a chunking algorithm that we spent several years with Microsoft Research coming up with how do you optimize where you break files in order to get the best dedupe results. So we apply that algorithm and break the file up into chunks. Now, once you've done that across lots of files, you'll find some of the places where you have identical chunks. We chunk them up, we apply a cryptography hash to that, and we compare the hashes. If they match, then we know that those chunks are the same. Once you've identified common files, then we copy those chunks into a chunk store, and you only have to copy them once, no matter how many files that particular chunk happens to end up in. In addition to the chunks, though, you have to have a way to get back to the chunks. So there's a chunk map that represents how to find those chunks for a particular file. And then we go back to the file system, And we put, instead of the file, we put a reparse point that points into the chunk store so that you can find the chunk map and go find the individual files. And once you have that written, you simply remove the primary data and all the duplication goes away and the amount of storage that you consume goes down. So let's talk about some of the design principles that we used as we built deduplication. These are applicable both to 2012 and to 2012 R2. But we started with a couple of simple places that we wanted to anchor the experience that we give you. So first of all, it needed to be a simple deployment experience. We'll go through the step-by-step later in the presentation, but the basic approach we took is take a volume, turn on deduplication, accept the defaults, and deduplication is running. So there's no complex thing that you have to do. You don't even actually have to understand how it works. Turn it on and we'll save space for you. There's some policies that you might want to apply, so we wanted to make those easy. I call them a couple of knobs that you can turn. One of the knobs that you can turn, for instance, is you might decide that certain files you don't want to, certain file types you don't want to deduplicate. So you could say a particular file extension you might want to duplicate, a particular folder that you might want to exclude from deduplication. And probably the most important of the knobs is a default time for how old the file is before we'll go optimize it. In Server 2012, that was 5 days, which meant that we would let the file sit for 5 days before we would optimize it. Why would we do that, you might ask? What we discovered is that when you look at real data in real storage, files tend to get written and then rewritten and overwritten multiple times, but the curve that describes that pattern goes down rapidly. So the rewrites to a file across all different kinds of file types tend to happen early on. So if we deduplicated it after the first hour or the first day, the chances are higher that it will get rewritten and we'll have to go re-deduplicate that again. So initially we turned it to be 5 days, but that's one of the knobs that you can turn. In 2012 R2, we moved that down to 3 days because the experience of customers using it was that they were getting great results, even turning it shorter. Another design point for this is that this is not a deduplication server that looks to your primary storage and deduplicates it. This is your primary storage. It runs on the primary storage. Going back to that architectural view of our vision of storage on Windows Server, it's the scale-out file server, or the file server that holds the data for your application service to operate against. That means it needs to be transparent to the primary server workload. It also means that we have to be able to back off when the server needs resources. And finally, and most importantly, the design point was no customer data loss. We can't lose your data. If there's one thing you buy storage for, it's to get your data back when you need it. And you want it back the same way that you delivered it to us in the first place. All right, so given these, oops, didn't change. Given these, let's see what this looks like on disk. So before you start deduplication, you have a volume. Let's say this volume is 10 terabytes, and we're going to use a hypothetical of, in this particular volume, you get 80% savings. So what does it look like as you deduplicate it, or as you complete deduplication? Well, first of all, there'll be some non-optimized files. Some of those files we talked about of files that you had an exclusion list. You said, don't deduplicate this file. There'll be some files that are small enough that there'll be negative cost savings from putting them into the dedupe chunk file. So there's some non-optimized files that are still on disk. Then you have a chunk store, represented by the orange here, and you have the file stubs that we talked about that point into the chunk store. So at 80%, you have 2 terabytes of data, physical data on the disk after deduplication, 80% savings. So you have 8 terabytes of available space that you didn't have before. What's that mean to you in practice? It means the capacity savings, of course, but it also means smaller, faster archiving, backup, restore, migration. You have fewer bits to manage as you go through daily operations. So 80% was a hypothetical. What can you actually expect in real life? Well, we took a look at a bunch of servers, at real live workloads on servers. For user home shares, it typically gets something in the neighborhood of 30%. Lots of user home shares are individual files that tend to be created separately. And as long as they're not shared, the deduplication rate is lower than it is with some other kinds of files. But when you clump all file shares together in an enterprise and go look at what's the aggregate savings across all the file servers, that tends to be a little bit higher, more like 50%. Not bad. Half of your capacity is now freed up. For specialized kinds of operations, you can find higher deduplication rates. So, for instance, a software deployment share, where you might have multiple versions of software or multiple copies of things, you'll get better rates. And VHD libraries turned out to be one of the nice sweet areas where we could get something in the 80 to 90% range for VDI libraries. All right, so that's real-life data, but it's represented on a graph. Ratwick, let's take a look at it in real life. Why don't you show them what it looks like on screen when you look at it on an actual server?
Absolutely. Everybody with us so far? Yeah? Okay, great. So we'll move away from slides for a minute, and I'm going to take you into a peek into a live server running in the lab. As Gene introduced me, I'm the test manager for Dedup, and this is a live server which we test on, and let's take a look at what we are able to see. So VHD libraries. So I have this set of VHDs that I am booting a bunch of VMs from. It's prototypical of a VHD library, which a bunch of VHD images and things like that. So far on this volume, I have saved, let's say, 10 files, and the actual size should be 81 gigs. Yeah? But I enabled dedup on this volume, ran optimization, and if I go back and take a look at the actual size on disk, any guesses? 10 gigs. This is actually from my server running right now, right? So the 80 to 90%, approximately in that range. One thing to remember is as the files get optimized, all the data gets stored in the chunk store, but as files get written to, we will have to recall the range of the file back into the file, so that because depending on whether the chunk is same or not, we will have to recall that. So while we say 80 to 90%, that's the general range that we actually see the savings in, but it really depends on your workload that you're running within the VM, and it's sensitive to that. So that's actually a live running server.
Okay, so when we showed this to people and they saw VDI with this kind of savings, the first question that they almost always asked, so that's in my VDI library. I'd really like to run those VMs out of that library, not just have it be in the library, copy them someplace else to be able to run them.
Right.
So that's what we did for 2012, R2, is go focus on a scenario where we had the ability to test it in a short period of time to get it out in this release. So we took a look at VDI. So let's take a look at this library where we have VDI VHD files and try actually running them in place.
Yep, we could do that. So and that's new, by the way. With Server 2012 R2, we are supporting VDI live files. So I have this VM, which I have saved in a particular volume. Keep a note, NVM, and I have this VHD. Currently, it's not optimized. It's 111.5 gigs, and I have this VM which I have booted off of that VHD. So I'll go to that VM, and to really showcase what impact deduplication has on a live running VM, we wanted to pick a workload which is sensitive to latencies, where you have constant streaming of bits coming in from the disk. And as you can imagine, based on the design that we have, deduplication is saving our chunks into our own chunk store. So there might be an indirection cost saying, hey, I have to retrieve this particular file data from this particular place. So there might be a performance penalty that you might have to pay. So I picked a workload which is on a VM, and if you're on a client, let's say you're running a video, right? And this based on and this is real live streaming video, which is being played. And as you can see, it's okay. Video is playing. But what I'm going to do is I'm going to go and start deduplication on this VM. So remember n volume. And to enable deduplication, you go to Server Manager, one click, configure data deduplication. And for those of you who have used Server Manager in Server 2012 R2, you might be familiar with this setup where you can say data deduplication, you can enable it. What's new in Server 2012 R2 is that we have created profiles that you can enable by default. So in this case, you can pick a profile of a VDI server, and we will use settings which are optimized for that particular profile. And so let me go ahead and enable that. And I'll pick the defaults, and I'll say, OK, go ahead and run dedup. So what this does, it enables deduplication on the volume, but it doesn't really deduplicate the files. As Gene was mentioning, our design is to do optimization in the background. But so what I'll do is I'll go ahead and actually run deduplication on the volume itself. So let me go here, and I say start dedup job and type. Okay, so that will start deduplication. Let me be there for a second while it starts. Well, it will run in the background. So while that runs, you will see that the machine is still up and the VM is still up and running. Absolutely no effect to the video. It's playing, and it will go on. And so while that runs, let's take a look. I actually, for the demo purposes, I pre-prepared an optimized VM. And so let's go to the optimized VM, which is actually booted off of a fully deduplicated volume. And I have exactly the same VHD, and this is actually running off of the optimized VM. And even on that, playing the same video, you'll hardly see a difference. It's exactly the same. And just to prove that I am actually doing it, I'll go to the VHD, which this optimized VM is running from. And if I look at the properties, it is only 1.7 gig on disk, while the actual size that the VHD should have been using is around 14 gigs. Okay? And this video is playing just fine.
So, yes, Windows Server 2012 R2 supports deduplication for live VHDs for VDI. And we'll come back to that limitation in a minute because I want to be clear about what's supported and what isn't. But for a minute, let's just think about what was necessary to have happen for what you just saw. So first of all, yes, CSV volumes are now supported. That was not true in Server 2012. Deduplication would only work on NTFS volumes without CSV. So CSV is now supported because recommended scenario involves scale-out file servers that run on CSV. Optimization of open files, and we'll walk through exactly step by step what that does in a minute. But what you saw Rutwig do was take a file that was actually running a VDI session and do optimization on the file while it was running. That's something that took a little bit of thought and a little bit of work to get done. In addition to that, we had to think about the optimization performance. In a VDI scenario, you would expect that you would have to be able to keep the optimization keeping up with the changes that happen on that volume. So we have to be able to optimize and have performance in the optimization in the background while the VDI files are running. And then, of course, the VDI files and the VMs need to be performant and responsive. Your customers aren't going to be very happy. Your users aren't going to be very happy if the VMs are non-responsive. So we had to be able to increase the performance to be able to make that work. So let's look at the scenario for this. As I said, we recommend using this on a scale-out file server. This is aligned with the architectural vision model that I showed earlier in the presentation. Hyper-V running on, VDI sessions running on Hyper-V, usually clustered, and running over SMB to the scale-out file server. Now, SMB is required. Scale-out file server is not necessarily required. It could be, you can use a traditional file server here. We highly recommend that you use a clustered file server with SMB3 and transparent failover. The scale-out file server will give you the parallel access from any node, and it's designed for these kinds of server application workloads. You might ask, why can't I just put deduplication on my Hyper-V cluster and be done with it? Well, if you put we don't recommend that. In fact, strongly discourage it, and it's for a reason. The reason is that typically you want your virtualization infrastructure to have high density, and you want it to have performance. The primary bottleneck typically in the virtualization side of this is CPU and sometimes RAM. Those are things that you want to make sure that the Hyper-V node has the ability to make those resources available to the VMs. If you put deduplication in the host requirements, where its job is supposed to be keeping the VMs happy and running, but if you put a job on the host itself, that has to take priority because the assumption is that the host has to be up and live and running and performant in order to be able to keep the VMs going. So putting deduplication in the host on the Hyper-V side will pull resources away from the VMs, and it will decrease the scalability and density that you can get out of a Hyper-V deployment. So SMB3 required, scale-out file server is recommended. There's another implication about this, because after you put dedupe on a volume, on a scale-out file server, it just looks like another volume. That goes back to our design principle. It's transparent to the workload. It just looks like a volume. Through the magic of clustered shared volumes, the data can be accessed from any node. But deduplication has a couple of implications that I wanted to share with you so you understand what's going on here. So you can access the data from any node, and you can go into Server Manager and look at the volumes on any node. So if you're going to manage and look at the volumes, check whether deduplication is on, set the knobs, as I call them, the time for how long you wait for deduplication or excluded files. You can see that from any node. You can also see what the compression is, what the deduplication savings are. The deduplication job itself, that process that goes out, does the chunking, hashing, identification of duplicate chunks, puts chunks into the chunk store. That's a process that runs on a node, and we actually make it run on the node that is the master node from the CSV perspective. So an implication of that is that that job runs on the node that owns the volume from CSV. And if that node goes down, so your node fails, the job will fail. It's clustered in this case, though. So the job gets restarted. The volumes are self-contained. The volume gets moved over, so it's owned by another node in the cluster, and we restart the job on the new node that owns the cluster. When the first node comes back online, the original node is available to run other jobs based on which volumes are owned by that node at the time. So the bottom line is you query each node for the status, but the jobs run on individual nodes. So let's talk a little bit about what it takes to deduplicate an open file. You saw it happen in the demo. We're going to walk through just the logic of how this happens. We're going to start with what's the deduplication process in a normal file. Well, you start with an unoptimized file. Use an algorithm to split that file into chunks. It's variable lengths, so they're not all exactly the same length. Identify the chunks and move them into the chunk store. And then you put a reparse point into the file system. And once that reparse point is in place, you can find the entire file in the chunk store, so you can get rid of the main data stream. That's pretty much what we talked about earlier. What happens if that file is open and somebody comes and writes to the file while you're in the middle of the dedupe process? So, same thing, we've got a file, we're carving it up into chunks. One of the chunks gets modified while the file is open, and the deduplication process is in the works. So what we do is we take the chunks that have not been modified, and we put those into the chunk store, just like we did before. But in this case, we have a chunk that's been modified, and so there's a hole in the chunk store map. So we removed the unchanged chunks, and now we have a reparse point that points to the chunks that are in the chunk store, and there's one modified chunk that's outside the chunk store. As Rutwik mentioned, when we're actually accessing a file that has been deduplicated, the same thing would have happened if the file had been deduplicated and then opened and modified. You would end up with a modified portion of the file, and the unmodified portion would still point into the chunk store. All right, so we've talked about what it takes to do VDI, open files, CSV. Now let's talk about performance. We come to that interesting topic. When we talk about performance for VDI, the biggest thing that people tend to be concerned about is what happens at 9 o'clock in the morning, or 8 o'clock or 10 o'clock, whatever the starting time happens to be in your business or culture. But my employees all come in, they all sit down at their desks, they boot up their VDI sessions, and it all happens within a relatively short period of time. We tend to call that, internally at least, a boot storm scenario. So Rutwik's going to show us what that looks like, because just like you might expect, nothing in life is free. When you do duplication, you get free space back, but as you might expect, there's some overhead associated with that. There's overhead on the read side, and there's overhead on the write side. When you write it, you have to do all the calculations, divided up into chunks. You saw the step-by-step of what we do there. And you have to write in multiple places. So there's some overhead in writing. Same thing happens on the read. When I get a read, I have to go read the reparse point, figure out where the chunk map is, go find the chunks out of the chunk store, reassemble those, put them in memory, and make them available to the reading application. So with that, we're going to take a look at what a bootstorm scenario looks like with deduplication.
All right. Thanks, Gene. So I'm going to show booting up several VMs from a normal VHD set of files and another set of files which are deduplicated on another volume. So this is Hyper-V Manager, and I have 5 VMs, which are these top 5, which are enabled with dedup. They are booted off of VHDs which have been optimized with dedup. And the bottom 5 are the ones which are booting off of normal VHDs. And I picked the last VHD of each one at the bottom screen to show as the VMs actually boot up. We can actually see it in action. And then on the right, I have a small application that we have written which tries to fire up these VMs almost simultaneously and tracks the amount of time it actually takes for the VMs to boot up. And we wanted to really make sure that we don't really have an adverse impact on the boot scenario. Because as Gene mentioned, since deduplication is storing the chunks in our own chunk store, there could be a performance impact. And especially when a lot of VMs are trying to boot together from the same set of files, we might be bottlenecking on throughput, we might bottleneck on other issues. So we wanted to not have an impact on VDI capacity. So on the left column is the normal volume, and the right column is dedup enabled volume, and it will show you times it takes to boot up these VMs. And by a show of hands, how many people think that how close will we be with regards to deduplication having an adverse impact? Just do you think that that's what we used to think? Maybe we thought that we'll have an adverse impact. So let me do this. Let me start all the VMs. Oh, and also I have performance monitor, and what I'm tracking here is the number of disk reads that are happening on both of these volumes. The red line is the normal volume, and the green line is the deduplicated volume. The reason for me tracking it is to see how many IOs are actually happening against these VHDs, and how then that will correlate to what performance am I seeing on booting up these VMs. So with those, I'm going to minimize the performance counter for the time being. Actually, let me start it first. So I'm going to start monitoring performance, and while we do that, once that is on, let me start these VMs. Okay, out we go. On Hyper-V Manager, you will see that all the VMs will start off in quick succession, and on the right, as the VMs start booting up, we will see them come up. So there you go. The TS sessions are coming up. This is the dedup and the normal. You're going on fine. And then let's take a look at the performance counters. So as I said, red is the performance counter for the one which is the normal volume, and green is the dedup volume. And we are monitoring the number of disk reads. The reason we are monitoring disk reads is because while booting up, we have a lot of disk reads happening. It's a read-intensive scenario. The number of bytes which are written are fairly lower as compared to the number of reads. And as these VMs come up,
dedup first.
Dedup got one first, and we will keep on going. What you will see on the right side, if you want to look at averages in this performance counters, is for an average, dedup was reading approximately 10,000 bytes per second on an average.
10 million.
And normal was reading substantially more than that. And there you go. These VMs are coming up. Dedup is actually done booting up 5 VMs in 80 seconds, and we are yet to see the normal ones come through. And what is really happening here is since deduplication has single instance or deduplicated all the chunks, and we have almost 90% savings, we are reading the same chunks again and again from our chunk store. So we are seeing an effect of actually those chunks being read. But not only that, Hyper-V, by the nature of it, actually does unbuffered I/O. So you would think that even if it's the same chunk, we have to read it again. Well, with deduplication in the picture, that unbuffered I/O gets converted to a buffered read, which means that the system is caching that I/O, and we are actually serving that I/O back from the cache directly. So on the perf counter, you will see the dedupe is done. The average I/Os that we actually read from the disk are substantially lower than we would actually from the normal volume. So not only is dedupe not in the way of booting up these VMs, we are actually doing better because of system cache actually serving up these reads. So you're able to scale much better with dedupe. So not only you save space, you actually save time as well.
Not bad. What do you think? Save space, better performance in this scenario.
Yeah.
I say it in this scenario. As I said, there's overhead. You'll be able to find places where you'll see that overhead. But we really focused on what does it take to make VDI practical with deduplication, and we think we've gotten it well into that range. So right, we talk about caching. This is just a little diagram to show how that works and what he's talking about. So the Hyper-V compute node sends an I/O request to the file server. Hyper-V is always sending non-cached I/O requests. The file server sends that I/O request down the stack to the dedupe filter as non-cached I/O. But because, as Retwig said in the first demo, because we have this profile for make deduplication for Hyper-V, we know that this is a Hyper-V request coming, and we know that we can convert that from non-cached to cached I/O. So we go to the chunk store. The chunk cache gets populated in system RAM, and then the next time you go ask for that same chunk, and remember in a VDI bootstrap scenario in particular, it's a whole bunch of images. Typically there'll be Windows 7 images or Windows 8 images, hopefully. They'll be reading similar, or actually the same binaries multiple times to be able to make that boot. So the dedupe cache is very effective in that simultaneous boot scenario. All right. We've talked about open files. We've talked about CSV. We talked about performance. At the beginning, I told you we'd do a little bit more step-by-step and talk about how you deploy and manage deduplication. So I'm going to start with a couple of high-level pictorial overviews, diagrams, and then we'll go through and give you a cheat sheet. So there's two modes for deduplication. And at a question just before the session started, is deduplication only for VDI? No. As we delivered in Server 2012, there's deduplication for general file servers. This is the capability that's most effectively used in things like a general file share, file server service, information worker files, home folders. That scenario continues to be available. There's the management that we talked about, to manage the schedules, manage the options, turning deduplication on and off. It's transparent to the users. In this case, if it's information workers, laptops, desktops, they're not going to see any difference. The one thing that is that does happen in this case that actually optimizes the experience for those is if you have branch cache in your environment, the deduplication and branch cache have been coordinated, so we use the same chunking and hashing algorithm. So for those of you that are familiar with branch cache, you know that if you don't have deduplication turned on, the first access to a file with branch cache on the server finds a file that hasn't been chunked and hashed, so it has to copy the file out in full. Then the server does the chunking and hashing process on it, so the second process or the second request gets the chunks that go into the cache. So you end up with deduplication having those chunks and hashes pre-computed, and you accelerate the benefits from branch cache. So general file server, VDI scenario, this is what we've been talking about much of the session. The interesting thing to note here is that the Hyper-V compute section of this deployment doesn't actually have to know anything about deduplication. Just like the information workers, laptops and desktops in the previous scenario, the Hyper-V server doesn't have to know about dedupe. For VDI, the deduplication server needs to know that it's Hyper-V asking for it, but the Hyper-V doesn't have to know about dedupe, which means that you can deploy this with Windows Server 2012 Hyper-V compute clusters. You don't have to upgrade those to R2 to be able to take advantage of deduplication on the file server. You do have to have R2 for the file server, of course. All right, so I promised you a cheat sheet. So we're going to do deployment and management of deduplication in 2 slides. Let's go. So, step 1, you got to decide what you want to do. Figure out what servers you want, what data volumes you want to deduplicate, make any decisions about policies and which knobs to turn. And you might want to take a look at evaluating what the savings will be. There's a slide later, I'll talk about this tool. So once you've figured that out, then you just turn it on. You saw Rutwick turn on deduplication on a volume. You can do it with the GUI, as he demonstrated. I put up here the PowerShell, so you can see it's just as simple in PowerShell. You have to add deduplication. You turn on it as a sub-role under the Windows Server file server. You turn on that feature, and then it's as simple as enable dedupe volume and give the name of the volume. You can optionally set the policies that we talked about. Finally, you can optionally initiate the deduplication optimization job right away. If you leave the default policy of 3 days and you don't start it manually, it means that the scheduled job will run, and the first day that it, after you've turned it on, it won't find anything. Well, actually it will if you have old data, but it will run in the background. If you want to do a demo or you want to see immediate results, you just run the optimization job on a manual basis. If you don't do that, it'll run it on a scheduled basis. And you can set the schedule for that. The PowerShell commands are there. All right, so for general file servers, that's it. Figure out what you want to do, turn it on, let it optimize, or you can manually kickstart it. For VDI, there's one more step. That additional step is that you want to tell it, or tell the deduplication service that you're using it for Hyper-V mode. One more caveat, though. If you're going to set dedupe on a volume and you want to put lots of VDI files on it that you don't already have, you have a challenge. The challenge is that you have more physical data than your volume will hold typically. So you're going to have to put as many files as you can onto the volume, run the optimization process, it'll shrink it way down, then you can continue that. But unless you have a volume large enough to hold all the files that you want to put on it, you won't be able to do that without having deduplication going on in the process. So that's what it takes to deploy. What does it take to manage? There's monitoring and reporting. Again, fairly simple PowerShell commands or user interface that you can use. Get the dedupe volume, give you the savings and the status, and you can get status of the optimization jobs. There's the maintenance and troubleshooting. We already talked about the ad hoc optimization job. You can start that anytime you want. There's a scrubbing and garbage collection process that, again, happens automatically on a scheduled basis in the background. Runs weekly by default. You can run it more often. It will go find places where there is data that can be eliminated. It will also do the scrubbing job, validates the integrity, and we'll talk a little bit more in a couple slides about data integrity. Finally, you can unoptimize a volume. Just like the caveat about how many VDI files you can put onto a volume, be careful with this. If you have a 3 terabyte volume with 10 terabytes of data on it, 3 terabyte physical disk, and you try to unoptimize that, you'll have a problem because we won't be able to get you 10 terabytes of data on that 3 terabyte disk. So you may have to copy data out. If you copy data out of a volume, of course, we deduplicate it on the way out. You won't be able to unoptimize the volume itself until the amount of logical data that's on the volume is at or less than the amount of physical space that you have to store the data in an optimized form. And as usual, there's some caveats. What's not supported? Well, boot system disks, boot disks, system disks, FAT volumes, and REFS are not yet supported by deduplication. The volumes have to be attached to the server. You can't use remote storage that looks remote, as in over a file system protocol, an NTFS or CIFS volume. They have to be local volumes to the Windows server. And that's logical if you think about it. We have to do a bunch of work to make sure that those writes hit the disk in exactly the right order in order to make sure that we don't have corruption. And if you introduce a remote file system on top of that, we don't have control over how the writes hit the disk, and you could end up with lost or corrupted data. VMs using local storage in a Hyper-V host, we talked about that. It's not supported, and it's strongly not recommended. Another thing that is not recommended or supported is databases, which make a particularly bad target for deduplication. Databases, the database applications themselves typically have built-in ways that they handle reduction in the size of the files, and they don't like a deduplication process getting in the way of that. It'll either screw up the deduplication layout that they have, or it will dramatically impact the performance of your databases. So don't do that one. And then finally, there's some files that we just won't deduplicate at all. If there are extended attributes on them, we won't do those. If the files are encrypted, we don't deduplicate the encrypted file. And if it's smaller than the average size of the chunk, you won't get any savings from it, so we just leave it in the general file system, as well as reparse points. Deduplication is available on Windows Server 2012 and R2. It's not on Windows Client. So a few other considerations. Upgrade and migration. So moving or copying files, no problem. We take the data out of the chunk store, and when you ask to move a file or copy a file, we give you back the file in the same way that it was written or copied in originally. You can access that file or a set of files in a volume over remote SMB from any version of Windows because we're, again, giving you back the full file in undeduplicated form. You can move a volume, like physical volume, from Windows Server 2012 to R2. You can't go backwards. You can't move from R2 to 2012 or to any earlier version of Windows. And then finally, some considerations on backup and restore. do individual file backup and restore. It's just like writing a new copy of the file. You overwrite the file, we write it into the file system, we come through and deduplicate it again, and everybody's happy. You can do a full volume backup and a full volume restore, and that's no problem either, as long as the file system and the chunk store got backed up and restored together, everything all matches. You can imagine, though, there's some problems you could encounter if you don't keep those in sync. If you have your file system consisting of pointers into a chunk store and the chunk store is out of sync with the file system, you'll find places where your pointers point to nothing or they point to something that no longer exists. And that can get you in trouble. So make sure that you don't do backups of just the reparse points without the chunk store, or a backup or restore of the chunk store without restoring all the reparse points. There is an optimized file level backup and restore using the VSS writer that we've provided. The bottom line here, though, is if you're going to do backup on a dedupe volume, just ask your backup vendor. A number of them work just fine with this. Check the version that you have, because some of the versions of backup solutions that were released prior to the last year didn't support deduplication for Windows. All right. So given that, we have one more little treat for you. We wanted to talk to you about deduplication and VDI density. So density is one of those things that customers tend to want. They want to figure out how to get the maximum number of VDI desktops in a rack or in a server. And as we talked about at the very beginning, as the same way that hardware and technology advances are changing the way that we can do storage, they're changing the way that you can think about deployment. And the combination of dedupe and those hardware changes give us some interesting possibilities to think about. In a world where you have rotating media, you typically have a couple of hundred IOPS per second on a disk. And if you need more IOPS, you'll tend to put more spindles. On the other hand, we have increasingly available, relatively low-cost SSDs. They'll have IOPS that are an order of magnitude or more faster than that, but the capacity is limited. So now how do you find workloads that match both the capacity and can take advantage of the IOPS of SSDs? Databases have been a good example for that, but many workloads haven't been able to take advantage of that and have the data in a small enough volume to be able to use the smaller capacities of SSDs and the larger IOP capabilities of SSDs. So we've decided we'd show you a little thought experiment about how deduplication technology and SSD technology can work together to take advantage of some of that. Ratwik?
Sure. So, yeah, it's almost 4 o'clock. Everybody with us still? All right. So, I have installed an SSD on my server, and what I'm going to show is how dedupe allows you to actually have more VHDs in the same size and really be able to still be able to do your day-to-day VM boots and things like that. So here I have two volumes that I've carved out of my SSD disk. Both are roughly the same in size, and on the normal volume, based on actual size of the VHDs, I'm able to fit in like around 5 VHDs. And it kind of fills up the volume. I have 45 gigs in this 5 VHDs. It kind of fills it up. And I'm going to show you booting these VHDs. But if I go back on my dedupe volume, since I was able to optimize, any guesses on how many VHDs I can put in?
Do I hear 10?
10?
20? 25.
25.
Let's see.
All right. 25 is a good guess, but it's actually 50. I have actually really filled up this disk, 50 VHDs. Ideally, it should have been taking around 461 gigs on disk, but since, as we are saying, that we actually see really high deduplication and compression rates on VHDs, I still got 7 gigs free, even after actually having 50 VHDs. But, well, I'm not that satisfied still, right? I have 50 VHDs stored, but can I use them? Okay, let's try that. So I go back to my Hyper-V manager, and I have all these 50 VMs configured in these 50 using these 50 VHDs, and then I have my 5 VMs, which are the ones which are booting off of my standard normal volume. To make it more interesting, now let's track some performance numbers also while we are doing that off of the SSD. Well, we are using the SSD so that we can actually get very high throughput, right? We want to actually have these VMs boot really fast, but since we are only doing 5 VMs there, are we really using that much capacity on the SSD? Let's take a look. So what I'm tracking in my perf counter here is the red line is of the normal and the green line is of the deduplicated VHD. And I'm tracking is the disk transfers per second. Captures, reads, writes, everything. So I'm tracking that. So let's see how much capacity of the SSD I'm really using. Let me. Oh yeah, I need to start it to monitor it. That is smart. Okay, so test VM 1 to 5. Let me start these. All right, they'll start in quick succession. They're going great, and I see activity on perfmon already. I'm using around 100 IOPS. Right, it's good. Goes to 200, 300, approximately in that range is what you'll probably see, because really you're not really using the SSD that much in terms of throughput. In terms of latencies, yes, definitely you will have a big bump because of the SSDs, but that's a separate point. Well, and at the same time, let me actually go ahead and start these 50 VMs to kind of see whether I can start these. Now I've compressed all of these into one volume, so let's see if we actually see any impact here, or do we use SSD efficiently. All of these start in succession, one after the other, and going back to perfmon, we start seeing actually more usage, right? Even the average usage over a period of time and the actual first time boot usage, you will actually see larger numbers. So you will really be actually start approaching the benefits of having faster type of media by actually condensing more on the same volume. So it's a double benefit, really. You compress more, but then you are able to leverage more of the investment that you made in faster media and of these newer data types as well.
Did I mention that R2 is not yet released? We're still working on some of the final details here. If you've been in some of the other sessions, you might have heard about the SSD tiering capabilities in Server 2012 R2 storage spaces. We'll play around with that and get a little bit more. We're not prepared at this point to give really detailed recommendations about how to tune those, but we think this is indicative of some very interesting possibilities on how to deploy VDI going forward. So a couple more things. I promise we're almost done. A couple more things I wanted to talk to you about. We mentioned data integrity and reliability. So historically, if you're worried about data and keeping your data safe, what you do is you make extra copies of it. Use things like RAID or mirroring. You add redundancy to your system. Deduplication, by design, is about removing redundancy out of your system. So if you take all of the extra copies of the data out of your system, what does that do to the integrity and reliability of your data? That's a concern. So I wanted to talk to you about what we do about that and how we help keep your data safe. So first of all, we detect. Deduplication runs on NTFS. We don't yet interact with REFS. RFS can do checksumming and do integrity streams and integrity checksumming on metadata. NTFS does not. So deduplication adds integrity checksums and validation on all the metadata chunks and the metadata so that we can tell if there's a problem. Then we add redundancy back into the system in the sense of we put extra copies of all metadata and popular data chunks. If you've got a data chunk that's used in 1,000 files and you have a bit flip in that chunk, you can screw up a lot of files. So where there are places that we have particular amounts of risk, we put extra copy and we have redundancy in the metadata. This is all in addition, of course, to whatever your underlying storage system does to protect against those things. Third, I mentioned the scrubbing job. The scrubbing job goes through and looks at all of the chunks, all of the metadata, looks at the checksums, and can figure out if there's anything that has been corrupted. If you don't look, you'll never know. And that's the state that a lot of people's data is. We think it's important to be able to look. And then when you do look, that gives you the chance to be able to repair. So we can repair, we do the scrubbing, we can detect that there is a problem, and then we will go repair that data from whatever sources are available. There's a couple of sources here that are rather obvious and one that's not. First of all, from the redundant copies we talked about earlier, if we have an extra copy, we can tell by the checksumming which one is correct, and we'll use that to replace and update the incorrect one that has been corrupted. Second, if you're using deduplication with storage spaces mirroring, storage spaces will have redundant copies, and we can tell whether or not you have the data integrity checks on the storage spaces level. We can tell which is the correct copy, and again, we can go repair and replace the corrupted copy with the correct copy. The interesting one, for me at least, is we can actually repair from the future. So what that means is that chunks have a unique signature, which is how we identify that it's the same as some other file. And if we find a corruption, and we know that we have a corruption in a chunk with a particular signature, then the next time we see a file that has a chunk with that same signature, we'll go replace the bad chunk with the new chunk that just came in, even though the corruption may have occurred sometime in the past. Finally, last slide. You might be saying, well, this is interesting, but it's still a bunch of work, and I've made changes to my system if I go out and turn on deduplication. And since I want all of you to go try this next week, we've made it easy for you. So there's a tool. It's called DDP eval. And when you turn on the deduplication role in Windows Server, that tool is available. You can go grab the binary and actually run it on Windows 7 or newer on the client. You can run it on Windows Server 2008 R2. You can run it against local volumes, and the tool, unlike deduplication itself, which has to worry about the data integrity, but the tool just is giving you assessment of what the savings are. You can run that against a remote file share. So you can run this on a Windows client and run it against a file server, and you can tell what kind of savings that you would get without having to actually go do the deployment. Then you can see how much you would save, and you'll go make the changes. All right. We'll take a question in a minute. I want to put up the last slide. This is a summary of the things that we've talked about. Hopefully I've convinced you that there's some value you could get from deduplication. We'll save you some space. The cost is effectively zero. It's in Windows Server 2012 right now. And for VDI, it's in Windows Server 2012 R2. And the preview of that is either out on the web now or will be in the next few days. All right, so with that, we'll take questions, and please fill out the evaluation forms. Yes? A performance impact on the file server. I believe we scale that back to prevent it from swamping your server. I don't know what the exact percentage is. Yeah, we backed it off.
Right. Let me just add one thought. Our optimization pivot was to always not have any impact on running workload against the file server, and that's why actually it takes longer for evaluating, because we actually have to go through each and every file, and we actually make sure that where you're running DDP eval is actually where you see the performance impact. So, but internally, no. If you have general purpose file server workload or something running on a collaboration share, it should not see any impact.
Yes. You have to speak up because the fans are loud. Does it what?
File history.
Oh, yes. You're asking, can you go back to previous versions
yes.
on the server? Yes.
Yes. Okay.
Okay, we'll touch you after.
Taken. We need to access the file system direct, so it's one level in directions. But if you use subs, yeah, it will actually fix it. I know exactly what you're saying. Makes sense. Yeah. Mm-hmm. Mm-hmm.
And now I've heard that you have some sort of a recovery procedure inside of the deduplication to restore from storage mirrors as well.
Mm-hmm.
So that kind of mitigates the fact that you can't use reserving file system for it.
I'm going to answer a slightly different question and then take this one offline because it's
people at the back are saying just repeat the question.
Yes, I understand.
Okay.
So the overall comment I want to say is that the limitations that we talked to today are about Server 2012 R2. I hope that we have communicated effectively that we're committed to the storage space and we were going to continue to evolve those. I can't tell you today what's the schedule for when we roll out each of those things, but all of the limitations about, I want to do deduplication on general purpose VMs on Hyper-V. I want to be able to do it with REFS. All of those kinds of feedback we've heard. We care about those as well, and we're going to be continuing to evaluate those and try to bring you the most important things as quickly as possible. I want to take your question offline because I didn't quite follow it. Any other questions? Yes.
Yep.
Say again? Not supported for... oh, yes. What is dedupe for live VM supported for, is the question. For Server 2012 R2, we've tested this and we're supporting it for VDI scenarios. VDI over SMB3. As I said, recommended against scale-out file server. That's not required, but SMB3 remote storage is. We know that you'd love to do it on any VM on Hyper-V. We would love to be able to do that. We think we've done most of the work for that, but we haven't been able to do all of the validation necessary to be able to support that. Yeah. You're welcome to go try it in non-production deployment or non-production environments and test it out. Give us feedback. If you hit any bugs, we'd love to know that as well. But it's not supported for general purpose VMs. If you go try it, our recommendation is that you make sure that you've set up your VM to have the OS on one volume, one VHD volume, have your temporary disk on a separate one, probably local, and then have the data for your application that runs in that VM be in a third disk, particularly if it's a database like Exchange or SQL. Put that in a non-deduplicated volume, run the OS on a dedupe volume, and tell us what you find.
Yeah.
But the official support is VDI for this round.
The crux is that a lot of the workloads are performance sensitive. And we have done significant amount of works in this release to make sure that in scenarios like Bootstorm or VDI scenarios, we are actually able to meet our customers' expectations with regards to the capacity that they are running with VDI or the latency that they want to see within the VM. That is not true for any general purpose workload which might be running. So we would love to get there, but in Windows Server 2012 R2, it's VDI.
Okay, we've got about 1 minute left. I'll take another question or two, and then we'll hang around and talk to folks afterwards. Any other questions that you want to ask for the group? Thank you very much for sticking around for such a late session on Friday afternoon, the last day of the conference. We appreciate your attention and hope that you have fun trying out dedupe for Windows Server. Thank you for coming.